How did you guys find each other?
It was just during COVID, so we had a lot of time on our hands. And I actually just reached out to Colin on LinkedIn, just randomly messaged him. Always like to call it kind of like a COVID love story, do some online dating.
What would be the one bit you would give them as a mentor?
What's really helped me is just understanding that things are going to take longer than you expect, and that's okay. Like,
where do you see Raise in a few years, right? Call it 5 or 6, or in any significant milestone that you want to achieve?
I mean, we wanna raise robot in every project in the US.
Hey everyone, and welcome to Bit Builders, where we sit down with the greatest minds building and exploring robotics in construction and space. Before we get started though, if you're a startup founder or operator responsible for innovation in your company, or you want a deeper, more insightful look into technology in AEC, you won't want to miss our newsletter. From deep dives into particular technologies such as AI, robotics, design, software, and so on. Hot takes from investors betting big in AEC technology, and advice on building tech companies, including the stories and takeaways of the most successful AEC technology founders. Head over to www.bricks-bytes.com and sign up today to get this exclusive material straight to your inbox. And now for the episode.
Hi, Kali. Hi, Gary. How are you guys?
Doing good. It's good. Thanks for having us, Gabriele.
Of course. I'm my honor. I'd love to, as I was telling you like 2 minutes before we hit record, you're the second, one of the few very early stage startups that we're having on Bit Builders. And I think, it's because you're building something extremely interesting, extremely niche. And I think the world should know about it. So why don't you guys just briefly introduce yourselves and we can take it from there.
Sounds good. So hi, my name is Gary. I'm one of the co-founders of Raise Robotics. I've been working with Conley on Raise for about 3 years now. Before Raise, I used to work on autonomous vehicles, did some work at Waymo for a bit. And before that, I was working with my professor from UC Berkeley to try to commercialize some of the research that we developed.
I'm Conley. I'm another co-founder, chief operating officer. My background's in the commercial construction equipment space. So worked with 2 large crane and rigging companies over the last 5 years. That was Big E Crane and Rigging and ML Crane Group. Worked as a project manager, salesperson, engineer. If there was a role in either company, I probably filled it at some point. It exposed me to pretty much every type of construction, residential, all the way through large infrastructure. Had to estimate, design, engineer, and deliver crane rigging projects and specialized projects. So gained a very good understanding of kind of the pinch points and qualms with equipment on site and how to optimize equipment for on-site delivery and execution.
Super cool. I think the audience has gotten a little bit of a feel of why I deem this team special. I think it's the mix. I'd love to double down on these past experiences you guys have had. I think it's a key it's a key piece of the answer as to why you started working on Raise. I think, the big picture is there. Gary was working on autonomous vehicle, and Conley was working in heavy equipment, construction equipment, broadly, right? But I'd love to, double down starting with Gary and looking at the tech side. What were you doing at Berkeley? How did that, transmute into your first early career moves? What has been exciting in the years before Raise?
Yeah. Well, actually at Berkeley, I did a lot of work in both research and startups. So I kind of got like a great mix of, both doing very technical work as well as seeing what it was like to start an early stage company. Even before I graduated, I was working with a startup at Berkeley that was trying to commercialize some electrical engineering research and turn that into a product. And that's an area where I just found I really enjoyed trying to take something that people have spent years on developing research and something that's very deeply technical and trying to bring it out to market. It was something that was very interesting to me. And especially since a lot of this research, it's locked away in labs, but it could make a really big impact on people's everyday lives. And that's something where I saw that there's a lot of opportunity.
Gotcha. What is it that, I'm really curious. What is the electrical? Sorry, that's just my like professional deviation to ask. But what was the electrical engineering work that you were working on specifically?
Yeah, so there are these two postdocs at UC Berkeley that developed a low power MEMS oscillator. So they're trying to take that and turn it into a product for some IoT devices. So basically being able to connect to things like Bluetooth or other protocols and reduce the power consumption that some of these wireless communications require.
Okay, that's awesome. What about Waymo? Why did you go work at Waymo? What was this? Was it just because it's a pool of great talent, or did you have a specific interest in autonomous driving?
Yeah, so at Berkeley, I actually did a lot of research well, at the time it was called Berkeley Deep Drive. I think they've moved back into Bear now. It's a research lab that focused primarily on autonomous vehicles. So I spent a lot of time just working in this domain, and it was definitely an area where I had a lot of interest. I think, I mean, I don't know if you've taken some of the Waymos around, but they definitely are pretty cool. And it's also an area where I think, robotics has really shined in not just, helping reduce bottom lines, but it could really make a big impact and improve people's lives. Driving is still a very dangerous activity, and there's a lot of room where autonomous vehicles can provide additional safety benefits just on top of, making it easier for people to get around.
Yeah, and I think it's one of the things that we've seen the most in terms of founders that are working on autonomous vehicles. We have one of the companies in the fundamental portfolio, Safe AI's retrofitting heavy equipment to actually operate autonomously. What we've seen is that, obviously, and this is just kind of like obvious and well known in the industry, you have this very big initial batch of cases where like 80% or 85% is really easy to solve, is really logical for the system to understand how to react. And then you have, as you fill up that remaining 15%, you have, really, really increasing marginal difficulty to tackle the next use case. So I think that's one of the areas where a lot of the computer vision in general has been applied to. And Tesla's done a really great job, and Waymo's done a really great job. There's a lot of other companies that are very nichey in this sector that we've that I've spoken with in the past, like ISE that is working in autonomous trucks for inside the fences of the yard. So basically, you're risking it when you cannot kill anyone. Almost, you can probably kill some operators that are working there if you really want to stretch it, but it's lower speed at least. Awesome, Gary. And Conley, what about yourself? What's your background? Where are you coming from? I hear Bert told me that you played football really at a high level. And you didn't expect that, right? So maybe start from that. I think it's a good one to start from.
Yeah, I'll say athletically I was very gifted in high school. My body just did not hold up. So went to college and then was on the powerlifting team at Penn State. So got quite strong and stopped lifting and now continue to eat at the same clip. So I've started to put on quite a few pounds. But still got some athletic bones in my body in case I need to break it out in pickleball or tennis against Gary. Yeah. Then while at school, studied structural engineering. But all my internships each summer were always in mechanical engineering. That was kind of my two passions. So I loved the macro engineering and the micro engineering, not electrical or computer engineering, but definitely on the tangible engineering side of things. After school, took a job with Apple as a DFX engineer. Didn't love the travel or kind of, I guess, my specific role in the company and decided to try my hand at going into construction. My degree allowed it to happen. Went to work with Biggie Crane and Rigging and really fell in love with just being on site. I mean, working for a specialty subcontractor, I think it's the best of all worlds within construction. Every single day is different. The projects are extremely dynamic. And then anytime I'm going to check out a new project, it's a new challenge that needs a new solution. So constant problem solving. I think, true engineering at its core, and allowed me to travel a lot, got to meet a lot of great people, and a lot of these people ended up being our customers now.
That's awesome. I kind of want to, you know, now that we know more about you guys, this is a combination of teams that it's really logical in my mind, but it doesn't happen that often. That doesn't really form that often. How did you guys find each other?
Yeah,
I think coming from completely different words. It's like,
it's definitely a funny story. I mean, it was just during COVID, so we had a lot of time on our hands. And I actually just reached out to Colleen on LinkedIn, just randomly messaged him. Always like to call it kind of like a COVID love story, do some online dating. But then we got a chance to, talk together a lot and work together even before we started Raise. We spent a lot of time just chatting about potential use cases, and as well as talking to a lot of Colleen's old customers, and I kind of let him take over this part of the story.
Yeah. So I think we started talking in December or January of 2021. And then over the next 10 months, we were putting together potential use cases just from feedback I was gathering from my current customers at the time. So looking at projects that statistically were going over budget or over expected duration for the crane and rigging rentals, and then started diving into the why with each customer. For each of these use cases, Gary had put together a robotic simulation completing the work scope that was holding them up with the crane and rigging rentals. And then we would pitch it to them and see if they'd bite on it. So we tried it with heavy infrastructure. We tried it with wind farm construction, tilt ups. There was a variety of use cases that we had dipped our toes in. But once we got to facades, and then specifically kind of high precision fastener installations, that's where we had an immediate feedback that, hey, if you guys can build this, we will buy it. And that ultimately is what led us to launching our first use case.
It's super interesting. It's interesting. So you did a product discovery with your Intel Conley and kind of like Gary's rapid modeling ability, and kind of iterated on that. That's super interesting. It's quite unique. How did it come to mind? Gary, what was your initial goal, right? Did you just want to start something of your own? Did you just see your skill set as something that was applicable better elsewhere while you were working at Waymo? What was the spark that led, okay, let me look on LinkedIn for a bunch of construction professionals that also seem somehow tech savvy? What was the search? What led you to that?
Yeah, I mean, honestly, I don't think I started doing this process with the goal of creating a company. I really wanted to just learn a little bit more about the construction industry itself. It's just something I'd always been interested in. I think, like, especially around the topic of how to build more dense housing, that's something that I really just wanted to understand more, like why construction was challenging. And like I mentioned, a lot of time for hobbies during COVID. But I think like after we started talking to a lot of people, it just got us thinking, because there were a lot of different areas of construction where it's just really hard to build. And I mean, for good reason, like, you're building some of the largest things that people have ever built in history. And there are a lot of challenges that come with that. And so that's really what led us down this path of trying to figure out where we could get a solution that used both of our skill sets out into the world.
Okay. Super interesting. I mean, you know that I had a different plan for this interview, but now I'm curious to see, where this leads us. What is a building envelope, for the benefit of the audience? Because I had to look it up myself. And way before this conversation. And then why building envelope? Why building for this rate?
Yeah. So building envelope, it's whatever is wrapping your structure. So the entire exterior of your building, there's a variety of different envelope types. Typically, you'll see on skyscrapers, they utilize unitized curtain wall panels. So these are all prefabricated assemblies that get shipped to site and then installed as a prefabricated assembly on the building. You'll see, typical unitized panels, stick-built panels, precast panels, they're all going to a prefabricated route now. So they all use the same anchoring system for the most part across the building structure. It makes it, from a robotics perspective, I think a very simple point of egress into the industry, since it's shared components across the board. I mean, if you look from one customer to another, there are times where a customer will run out of certain components and they'll just purchase them off their competitor because there's that much similarity in the components. And then as far as fastener types used, it's the exact same story. So there's only a handful of fastener types, which really ultimately limits the variability in what can be a very chaotic environment.
Okay. So let's picture this for the non-technical listener. You have a prefabricated panel that you're hanging off the edge of a building with somehow standardized hangers that need to be fastened to a slab of concrete that has been built. And what you've been building around is, how do we standardize install of these fasteners, of these hangers, sorry. How do we fasten them with a robot? And that's your initial use case. Did I explain it correctly?
Yeah.
Yes,
So I would say
So
it's definitely our initial use case, but right now what we've seen is that with building envelopes, it's a very complex part of the building because there's a lot of requirements on it. It's literally what stands between the building and the external environment. And as a result, it has to be installed correctly, or else you get a lot of issues with water leakage, inefficiencies, and then in the worst case, potential structural issues. I think what we've seen is that there's a lot of parts of the scope of work where there could be a really great application for automation. A lot of the work, it's very simple. Like you mentioned, the first use case we developed, attaching fasteners. That's not actually all that hard for people to do. There are things like caulking where it's very boring and it's very easy. But because all of this work takes place at the edge of the building, where people are literally standing at the edge of a cliff and trying to do all this work, sometimes literally hanging off the side of the building to do it, it makes all of the work instantly a lot more challenging, even if the task itself is simple. And that's where I think we see robotics can really shine, where you're building a robot to do things that are either physically impossible or very, very physically demanding for people to do.
Okay. I'm interested. What's the standard, right? So do people get tethered with, I'm a climber myself. So I would have fun to be, put on a harness, just put a clip on top, plant a bolt, clip my rope and then just rappel down with a gree. But, how do people do people actually do it this way?
Yeah, so I'm a climber too. So I think that was one of our unfair advantages is I'm getting used to heights. But as far as you do have to be tethered, there are very strict regulations around safety when you're working at the edge of the building. You have to be wearing fall protection. There are certain engineered requirements that need to be met. So all of that, it's very standard. But I think the challenge is, even though you have all these protections in place, it's still not really a very fun job. Some of the biggest challenges are so for example, if you're doing it in the US, a lot of the work is done without scaffolding. And so you have to be actually pretty much physically reaching over the edge of the building to do some of this work with the fastening. And that can be very comfortable. And in some cases, if you have limited maneuvering space, for example, if there's just not a whole lot of space at the edge of the building to do your work, then it can be really hard to move around and there's a lot higher chance of falling.
Okay, clear. And then I'm interested because you said something before. The envelope is what really just stands between the internal, what the building is protecting, the space the building is protecting, and the space that the building is protecting from, right? So I want to try to understand, what are the KPIs that matter, right, for a good envelope? Is it leakage of air? How much does this drive performance of the building? I can imagine that's a lot. And how much of this translates into risk for the trade subcontractor? That's something that's really interesting for me.
Yeah, I would say For exact specifications, I can't give you those. Every single company has their own kind of requirements. So it's a mechanical system, right? And it's designed to be installed with a certain tolerance. Like the actual physical building needs to match the design to a specific, within a specific, like there's some variation that's allowed. But what's happening, I think, on site is that you're building such a large building, and it can be hard to make sure that every single last piece is installed to specification because there's so many, right? Like a typical floor, we said there's usually around 160 panels, 160 brackets, and all of those panels and brackets, they have to be aligned perfectly. You have to make sure everything's clocked correctly. And, you know, when people do it, there's a chance of missing one small piece. Well, one small piece, if you miss it, there's always a chance that it could result in a much more serious problem down the line. You're just trying to make sure.
Hey listeners, I want to take a quick break to remind you about the Bricks and Bytes newsletter. If you're interested in learning about the technology shaping the future of construction, you won't want to miss the valuable insights we share each week. To get this exclusive content delivered straight to your inbox, head over to www.bricks-bytes.com and sign up today. Link is in the show notes. Back to the show.
It's hard to make sure that everything's perfect when you're building a building that's just that large.
No, it's fully clear. I think what's very interesting is that this is a very niche market to be operating in, but that's actually not a small part of the building value. Like the building value is a lot driven by that. I was reading before coming in, about 20 and 30% of the entire building value is in the envelope. And that's because a lot of the, well, first of all, there's a lot of MEP that has to be installed at the interface between inside and outside. And then yet again, those panels are literally what's making your building, free of leaks, where was actually sustaining the temperature inside. And those glasses are actually, for when it's made of glass, they're actually extremely heavy. They're thick. So there's a lot of heavy lifting to be done. And when I say heavy lifting, I'm also looking at Conley. I was, working with cranes before, and doing powerlifting too. So what I wanted to like dive into is how does one even start with a business like this? Drive me through, once you identify that use case, what'd you guys do? Did you, get together in a room, started thinking on something that was physical, and what happened then?
Yeah, I mean, we really try to focus on getting out in the field as much as possible. I think with my experience in robotics, I've seen that a lot of times building a robot, curing in a lab, and then trying to get into the field and hoping it works that's a great way to do it. There's a lot of things that you don't design for because you just never tried it out and you miss a lot of corners. And some of the times, if you miss something big, then you have to go back to drawing boards, start from square one. And so we want to try to avoid that. So we really try to spend a lot of time going to the field and testing. It was actually kind of funny because the first, test proof of concept we did, we went to one of our partners and we pitched them this idea where it was like, hey, we're going to try to build a robot to do this. And we showed them this simulation that was like extreme, like it took a day to set up and it was like not working. We were just like, hey, like, is this possible? Like, can we try to get on your site? And then the next week, we get a call back and they're like, can you visit us in Sacramento? And I go to Sacramento and he's like, and then I talk to the site super and he's like, hey, can you get the robot on next month? And like, can you maybe give us 2 months? Cause we don't have a robot yet. And this is just wrong. So that was a good experience, but yeah, that's how we got started. We were able to get on that project pretty quickly. Our first robot, like, because it was so short notice, it was extremely like rough. It was just, a lot of wood and metal, just really trying to see if this was possible. And luckily it was possible. So then from there, started making more iterations of the robot, really trying to always take the next design and put it in the field and test it and see like what went wrong and make sure that we kind of addressed all these issues. We really tried to focus on making, one of the things we really tried to focus on was making the robot as easy to deploy as possible. That was one thing where, like, because we did it so much, like getting the robot into a construction site is actually a lot harder than you think, especially once the robot starts to get bigger. That's something where we had to like do a lot of work on to make sure that it's easy to set up, easy to lift onto the building. It fits in all the standard hoists. That taught us a lot. And, you know, that's kind of how we got here today.
Yeah.
Tell me more about that.
Isn't it?
Yeah,
Double
exactly.
click on that. That I think is one of the most underrated aspects of early deployments is making sure your first day goes seamlessly. It's the first impression with the customer, the first impression with a lot of people on site. If you make something simple look difficult, that's going to be their just thought of your company or your existence. Doesn't matter how well the robot works once it's started, but the fact that you couldn't move it from point A to point B in an efficient manner, it does not bode well with a lot of the people on site. So that was a constant challenge with us. Initially, we had to disassemble the robot and then reassemble it when we got on site, which was extremely challenging. That took a lot of time. Then we streamlined it so that we had better packaging that we could forklift from any direction. We could rig it with a crane. And then we integrated those same design elements into the actual chassis itself. So now we can pick it with forklifts under the tracks. We can pick it overhead. There's multiple ways that we can move it around the job site. I think with any construction equipment, flexibility is number one in your design choices. If you're counting on the construction site having the hoist up at the right time, you're going to screw yourself at some point. And it's happened to us before where, you know, the hoist should have been up 2 months ago. And for whatever reason, the GC's been pushing back and hasn't put it up, or the tower crane came down, or the tower crane hasn't been put up yet. There's no way to actually egress the job site efficiently. So having optionality, it's a key piece for early construction robotic startups.
Yeah, no, that's really clear. And wait, let me help the audience visualize it, because I've seen pictures of it, seen some videos. Oh, have you used your robot? What does it look like?
Yeah. So the way that we describe it to customers, it's like a spider crane, but to the audience, I would say about the size of a small smart car.
Okay.
1,500 pounds. It's 38 inches wide, 72 long with arms out, and about 72 tall. So fits through all standard commercial doorways, fits in any hoist that's on a construction site as well. So it was designed with the, I would say, most constraining egress elements in mind.
Okay, but not a small thing.
Not small by any means, no.
Okay, that's clear. So what was the initial so here's the problem with a lot of the construction robotics companies that you have out there, is that it's really hard at the beginning trying to find a design partner that really trusts you and accompanies you in the development of the robot. Because one thing that's extremely different, and we repeat this, and I think there's one episode in this podcast series that I think really reveals the ins and outs of that specific concept, is the one with Henning Rodell, former lead of robotics at DPR. What he said is really key, and I think it's something that's going to stick with me forever, is, you know, you have robotics, the whole point is basically moving around an environment that doesn't change, or at least understand. It's easier for the robot to be in an environment that it knows. But construction, the whole point about construction is changing the environment that you're in. And so, and adding more things and, you know, executing workflows one after the other. So the way you combine this from a product development standpoint is to have the right partner be there with you and explain what every single step looks like. If you don't know it, and it's unlikely that you know it, and, you know, unless you worked 20 years in the industry, you don't know everything that's in that workflow. And every contractor will then have some of their requirements be fulfilled. At the, you know, on the robotics startup side, you have the founders that have been working in the lab. Well, not specifically you guys, since, you know, you told me it's, you know, the field was almost one of the first labs that you guys had, but you have a control environment robot that now has to, you know, develop features and understanding of the environment that it's operating in. So how did this work? This, you know, interlocking, expectations and just feedback from your early design partner? And how did this help you grow within, within the product development roadmap?
Gary, I'll talk about the customers first and kind of the partnerships. I mean, for an early stage company, the most important thing is establishing the right potential customers and the right design partners. For us, we got plugged in early with Henning. So shout out to Henning as usual. You need to have strategic alignment on your goals as a company. Your long-term vision needs to be aligned on, but they also need to have an intrinsic understanding of some of those challenges, like you had mentioned, that are gonna pop up along the way. And it's those conversations with those partners that really, I would say, allow you to confidently quantify variability experience in the field, highlight conditions that are atypical from their experiences. And even outside of that specific contact, whether it be like your head of innovation or anyone on the operations table, anyone in the field, that's like field input is extremely important as well. I mean, no one's going to know their job better or your job that you're trying to accomplish better than the people that are doing it manually. So you need to have that communication line established, and that needs to be an open communication line. So we're blessed with good customers out of the gate, good partners. There's definitely, I think there's bad partners that are out there for early stage companies. If you try to oversell your technology, you're going to end up with your back against the wall. So make sure you're being honest about where you're at with your technology, and just make sure you have that strategic alignment long term with the company that you're going to be working with. That's ultimately what allowed us to like get more comfortable with deploying with unknown variability in the field, since we did kind of establish a good bucket of what to expect in our deployments. I think, Gary, I'll let you touch on kind of like the technical side of it.
Yeah, I mean, I would say like even on the technical side, we can talk a lot about like specific technologies like sensors or, things like motion planning or AI, but I would say like it's really does come back down to actually more about the relationship with the customers and being able to experiment on site. I think especially with construction sites, and if you're focusing on a specific application or a specific set of applications, there is going to be a limited amount of variability. Like at some point, you aren't really working out in the wild, right? Like you're working on a site that's being designed by people, and there is only a certain number of elements that you have to deal with. And within that kind of limited variability, it's definitely possible to get a solution to work. But I think like what's really important is just being able to get that information from your customers about like, okay, well, this is kind of like what designs look like in the past, and being able to then use that information and use the experiences you gain out in the field to inform how to actually design your solution.
Yeah. And it's interesting. What's the user interface piece there, right? So, in a logical timeline, you're understanding what the workflow looks like. Then I imagine, and that's what I love to have you speak about. You'll control the robot, and you'll do that work by controlling the robot and then yourself. But then at some point that robot will have to be left to the operators on site who are construction workers, and will have to operate it like a tool, I can imagine, right? So what's the product design, philosophy there? And then, if we can speak about, it would be really interesting to understand, how do you think of user interfaces? Do you want to have a field engineer, dispatch to the site forever? Do you want, the customer to be operating this? What's your thoughts?
Yeah, our goal has always been to make sure that we're delivering a tool that existing construction workers can use. I think that's very important because, first of all, I think like existing construction workers, like I think there are a lot of stereotypes, but we found that people on the field are actually very technically capable, and like they're very good at their jobs, and there's a lot of understanding of construction sites and field work that they developed over their careers that is very important. That even like if we were to go on site and have field engineers operate robots, that they would be lacking. I would say as far as the UI goes, we really try to make sure that we're not requesting additional information from our customers they don't have to give their crews today. That's something that we've seen like robotics companies in the past really struggle with. And I think that's an area where it's going to be like, it's going to create a really high friction point during the sales process if you need customers to spend a lot of time preparing information in order to actually and really changing their existing processes to get these robots to work on site. And that's something that we really want to avoid.
What's then the KPI that the customer should be looking for improving when getting raised on site? Is it time to execution? Is it quality control? Is it through size? What is it? Where in the P&L of that contractor are you trying to make an impact?
I think it's safety number one, and then I would say quality control, and then productivity. So like you had mentioned, I mean, we're able to offset if it really depends on what the customer is looking for. I mean, there's different value that can be derived depending on what the customer's team is structured like. We work with customers that struggle to find field labor to staff their projects. It ultimately limits the growth of their companies. By establishing a robotic baseline, it allows them to scale across all of their upcoming projects more comfortably without having to hire local service teams that might not have the technical capabilities to complete their installations to specification. And then we have more advanced customers that have never had access to all of the project data that the robot can generate for them. So, for example, on a past project, we didn't even realize it was valuable until the customer realized what we were capable of generating. So we're completing the bracket installations, and we're generating an XYZ CSV installation log that shows exactly where the bracket is versus where it's supposed to be. In lieu, you can also highlight any issues with the concrete slab that's behind it. So if it's long, if it's short, if we're missing embeds, or if they're rotated, these are all things the robot picks up on. And the customer traditionally is not finding these issues until they actually have manual fields in the team completing the installations. So having the robot being able to quantify deviations from plan conditions, it allows them to either get ahead of rework or to make adjustments in the factory before panels get shipped out to site. So again, kind of depends on the customer type, but we've seen value. Everyone has seen value in safety. I think that's number one for us. It's the easiest thing for us to sell. You're not having to set up your edge guarding in the same way. You're not having to set up your high lines or tie off. I mean, tying off, climber or not, when you're doing it every single day, it really sucks. I mean, it's fun, I would say, for like the first couple hours, but when you're having to reset it every 30 minutes to an hour, it's a pain in the ass. So everyone values the safety aspect of it, and then quality and production. It really just depends on where the companies are at for our customers.
Okay. Walk me through that analysis that you did mentally, right? You've been, we like in general to look at what is the founder's perspective on the ROI that they're bringing, right? So double click on it. What is it that you are improving as a P&L line? Is going to be, definitely going to be the worker, the absence of 2 or 3 workers from the crew that was installing. You only need 1 or 2, I can imagine. Walk me through that process, that mental process of understanding the labor economics and translating it into robotics business model.
Mm-hmm. Yeah, I think the easiest way to think about it, traditionally the process that we're completing now, so bracket installation, layout, and inspection, this is 6 to 8 people that would be required for these 3 scopes of work. With the robot, you can maintain production rates with just 1 person in the robot. So instead of thinking of it like, oh, we're going to be laying off 5 people and maintaining 1, you have now 5 people that could do as much work as an entire crew across every project in your portfolio. You don't have to carry that overhead as a larger kind of macro. It allows you to be leaner and more accurate and maintain same production rates at the end of the day.
Okay, as simple as that. That's fully clear. It's interesting. That is a theme, right? The theme of replacing labor. It's very misleading. We have not seen, we yet have to see, robotics technology that on site, especially for construction and traditional industries in general. I'm talking even about robotics inspection, right? I really still have to see, after probably hundreds of these startups, who is actually displacing labor. Labor is being repurposed in a more efficient manner. Also because there's not much net new skilled labor that's coming into these trades. So you're not really replacing much, because if you look at the flows, the in and outflows of labor within these trades, it turns out that the net is negative. So you need to fill a gap. And that's actually it's really difficult to balance. It's really not a uniform problem to solve, but it's one that in net is actually helping companies staff better. This is very interesting. What is the market like in the US for these systems? The systems of building envelopes, kernel wall. Who's using it? Because single family homes don't have them. So where are they placed? Don't have that. Not all of them. I don't know. Colin. I saw you smiling. Maybe they do. Uh, my single family home in Italy does not have it. But I don't know. And then
Mine too. If you go around Cupertino, we are starting to see a lot of residential homes that have started using unitized curtain wall as kind of the next design element. So yeah, it's out there now. It's not cost effective, but it is being used.
Okay. So where is it that it's cost effective? Exactly. Probably that's the better question.
Yeah, it's at scale. So you're looking at mid to high rise construction, typically 5 stories and above. That's where you'll find a good market, with unitized curtain wall and just curtain wall facades in general. Very good for, I would say, larger vertical structures. You'll see them in universities. You'll see them in hospitals. You're starting to see them in industrial centers. It has not been, I think, limited by any one industry or one vertical, but definitely most popular in like commercial and office construction.
Okay. And what is it that what's the market dynamic there? What's the market structure? Because some of these trades are really fragmented. Some of these trades are actually very, very concentrated in top, 10, 20, call it, contractors. And I know for a fact that in Europe, for example, some GCs are probably the exception to the rule, but they themselves are taking the trade in-house and setting up the manufacturing facilities to make these prefab curtain wall and then install them themselves. So what's the landscape like in the US?
Yeah, I would say, it's pretty top heavy. I think if you look at any specialty subcontractor, any MEP structure or facade company, typically it's like the top 50 in revenue. That's going to be like 95% of your actual market. It's very easy to become a contractor. I think that's well known. And the assumption is also, it's super easy to become a contractor. So it's a super fragmented market. It's extremely difficult to become a good contractor. That is a fact. So you're not going to see much shuffling in that top 50, especially not the top 10. For our customers, we have customers ranging from 150 to over 500 million, and even international customers that are in the billions a year in revenue. So very large companies, very established, and they're just focused on these facade markets currently. We are starting to see, I think, a larger trend, like you had mentioned, with the restructuring of, what is a GC actually doing on projects? If you look back 20 years, especially the last 20 years, there's been this constant trend of mitigating liability on the GC side of things. So instead of actually performing services on their own projects, they just own the means and methods and essentially the process at the end of the day for having other people do the work on their projects. And it's just liability. That's the plain cut liability. If you're able to mitigate the risk and ensure project deliveries on time, safely, and within budget, GCs are interested in taking back some of those scopes of work, especially if they're related to the structure, MEP, or facade. So you hit the nail on the head. That is a trend that we're kind of seeing now. It's probably not going to be in the next 5 years, maybe longer term, 10 to 15 years. We'll start seeing GCs start self-performing more work by using automation as kind of that moat for them.
Okay. Interestingly enough, you're there with a robot. You're installing the facade. I want to pick your brain on where do we go from there, right? Your robot is there. I can imagine, something, after or before that trade could be an interesting, workflow to tackle. What's your vision on your robot expansion of scope?
Yeah, I think there's a lot of opportunities in construction to introduce automation. I don't think you'll get fully automated in construction anytime soon, but I think there's a lot of work where you, like I was talking about before, it's really challenging for people to do, or it's almost physically impossible. And that's where we really want to try to tackle tasks with the robots. We really have a lot of requests from our customers for additional scopes of work. So for example, some things we're working on right now with our customers are in drilling for structural retrofits. That's an area where, you had to drill hundreds of thousands of holes for a single building. And it's a lot of very challenging work for people because it's really hard on people's shoulders, on their backs, and it's really highly repetitive work, which makes it good for a robot. Down the line, we've had requests for things like doing caulking and welding. I think in the long term, what we really want to do is start turning our robots into more of a platform for construction automation, starting by focusing on buildings. I would say like with commercial buildings, this is an area where you do see very high standardization in the construction industry. Every building usually the same materials. It follows more or less the same schedule. And you can see even between companies, there's starting to be like very standardized designs. Like, there's a very common pattern of how people design these buildings, even across different subcontractors. And so that's an area where automation can really thrive because of that. And what we want to do is develop a very flexible robot that can be capable of doing a variety of different tasks. And our strategy here is to have a mobile manipulator platform. So basically the ability to use these arms to safely in the construction environments to do different types of work. And alongside it, develop basically a toolbox for robots, a set for different end effectors, things like the things I was mentioning, the grippers we currently have, drills, caulking guns, and be able to have our robots use these different tools in different settings and be able to have our customers essentially mix and match these tools in the future to automate whatever types of tasks they want to automate.
That's super interesting. So your approach, to kind of recap it, to product platform as opposed to a single product, is to have a base that is, what Conley described, when we visually sized it, as a base with robotic arm or anything that's movable, that has possibility to basically accept interchangeable end effectors with which you can do different tasks. How does one build software for that? I can imagine one thing should be common is understanding where you are, right? And then everything can come from that. So how do you think of writing software already to prepare yourself to have zero technical debt when you're going to scale into a robotics platform? Because I can imagine you can do one task with kind of like a bit of a sequencing of, patches and holes of if-else statement, but I don't think that works at scale when you're trying to become a platform. So what's your philosophy there?
Yeah, luckily we've already moved away from those if-else statements, the finite statement.
I can imagine.
But I think what's important with, I guess, like how we've approached this is that we try to find some commonalities. And like what you're mentioning, one of the biggest things that's really important is figuring out where you are on site, positioning and localization. That's something that we feel really focused on at the beginning. And the second most important thing is after you figure out where you are, you have to also figure out what's around you so that you're not running into stuff and you're avoiding obstacles on site. And that's also another area where we've done a lot of work on perception. I think what we really want to try to do and is try to figure out how to build up kind of that base technical foundation that's required to do a variety of different tasks and make sure that's in a really good spot, and then build on top of this foundation to then tackle specific applications. And what we're trying to really focus on with our current applications is finding things that are really highly repetitive so that we can build kind of templates out of these applications. So for example, a template for doing layout, a template for installing brackets, template for drilling. And then be able to use these templates in different settings.
So people don't usually think of this, but in the spectrum, right? You have tools that you have to activate by pulling a trigger, like a screwdriver. And then you have something that's like iterative. It doesn't really matter where it goes, which is something like an autonomous vacuum cleaner in the house, where it doesn't really matter where it goes. Yeah, one can say, yeah, I want to optimize the area that it's, but in the end, if you really run a random walk in the entire apartment, you'll probably clean it all. And then there's another class, which is you need to be able to activate it yourself. So an operator needs to be able to use it. And there's a very narrow margin for error because you need to be placed at the specific, in a specific place. And then you need to move your arm in a specific place and then use certain torque that, take a QA, QC type of steps. So pictures, torque readings, etc. And then retract, go back, and then go to the next step. I think that's something that it's not obvious. What's the closest analogy to that? Do you ever use an analogy to explain, what this development looks like?
Yes. I think I think with a lot of the construction robotics that I see right now, I think even in the near future, I think we're going to be somewhere in the middle between those. So I think the closest thing would be something like a CNC machine. If you ever use those. So, CNC machines run off a lot of software. It doesn't seem like it, but there's a lot of actual, behind the scenes programming that you need to do, in order to get CNC machines to work. But the thing is what you have to do is you have to give them kind of a basic understanding of what you're trying to accomplish, right? You need to have a CAD model and then you can, then indicate and then there's some software that's used to turn that into a CAM program. And that's what takes care of a lot of the work around actually controlling the motions. But that's something that you don't have to program manually anymore. Now that's something, as long as you give the software a starting point and some general instructions, the software can take care of a lot of that stuff behind the scenes. And that's kind of a similar approach of what we're trying to do with the robot. It's not designed to be something that's completely fully autonomous, it can do everything by itself and general purpose. But instead it's something where if a worker is able to give the robot a good starting point, tell it roughly what it needs to do, the robot can take care of all of the very repetitive and sometimes very physically demanding tasks.
Yeah, I love the analogy of the CNC machine. So for the benefit of the audience, a CNC machine allows you to cut different things. Let's call it lumber, just to, for the sake of simplicity. You can cut a lumber board in different, or a lumber, anything, a lumber block if you want, if it's a 3D one, but call it a lumber board with your own idea of what you want to cut. So you have a CAD model that just shapes your cut. And then the CNC machine will give you instruction how to place exactly the lumber board and will tell you, okay, and then, leave it there and then I can cut. Right? And that's kind of like the computer that talks back to the human operator and tries to get, the human operator to do something that the computer cannot do and the machine cannot do. It actually allows for much more flexibility than completely autonomous systems today. We don't know if complete autonomy in robotics, it's 2, 5, or 10 years away, but I love the analogy. Makes a ton of sense. I never thought about it. What have you been think, CNC machines just made me think of manufacturing. I think one of the biggest challenges with a robotics business, if you really want your robots to go out at scale. So if your robots don't, cost 3 million each, so you need only a handful of them to have significant revenue, you're going to have to produce a lot of them. You're going to have to actually have a fleet of several robots that need to be operating at the same time. What is your philosophy around running a lean manufacturing motion? Everything, right? So from what components you've been choosing, what type of financing, if any, you're applying to them. How many would you want to get in the near term in terms of fleet? When you think about manufacturing and filling up a big hangar with a bunch of Raise Robotics robots. Yeah, what's their design philosophy there?
Yeah. I think one thing that we really focused on is trying to avoid, I guess, recreating the wheel, for a better term. We want to try to take advantage of a lot of the advancements in robotics that have come out over the last few years. And we know that as a small startup, we cannot build a lot of these sensors or arms or chassis better than other companies who have been doing this for years and have the capacity to do it. So we're really trying to leverage existing off-the-shelf solutions. And with a lot of the parts on our robots, especially things that are more complex and that need to be reliable, that's where we try to pull parts from other suppliers. Like I mentioned, sensors, things like depth cameras, force torque sensors, and then the arms themselves that we use on the robot. We do take a lot of these parts and we integrate them, but even that is a challenging process in itself in the design phase. Putting together things in robotics is a lot harder than you would think at first glance. And as a result, because we're doing a lot of this integration, we can now leverage a lot of our suppliers' manufacturing capacity as we scale up. And that makes things a lot more straightforward. And then I think the other things you mentioned were around financing, right? That's an area where we are actually already currently talking with equipment financiers and banks. So we do see that it's definitely a good idea to be able to finance these robots. I think because we're currently selling our robots as more of a equipment rental, it does make it quite easy for us to kind of match that with the financing rate. Like we have a monthly revenue generation and monthly payoff. Those things match up quite nicely.
Right. Yeah, because the thing that we will need to turn construction robotics into, we've said it's tools, and tools are rented, even in two layers, right? Tools are rented at the job site, but it's also likely that the dealership or equipment rental company that is renting you the robot, it's himself financing that robot with external capital. And so these layers that go from the manufacturer down to the end users need to be there for good cash flow management of the business, and it makes perfect sense. How do you? It's interesting, for the benefit of the audience. How do you guys find capital for equipment financing of novel, never even proven robots? What's the first call at a bank like? Hey, I'd like a equipment financing. What do you want to finance my robot? Like, how does that work?
It's like taking out a loan if you want to go to the casino.
Yeah, exactly.
Yeah.
That's what it felt like to me. As an asset manager, like, hey, I don't know, dude. So how does that work?
So I would say there's two sides of the coin. Like the first is like traditional banks and equipment financing firms that typically don't work with startups. Mm-hmm. That's where I think, because we do a lot of integration of existing components, it actually makes the conversation a lot easier, because all the parts, we're not building them from scratch specifically for this one purpose. We're repurposing a lot of these components. That makes it easier for them to write them off as collateral, because it's something that they can sell on the market. If we take a look at the other side of the coin, there's actually a lot of firms that have popped out the last few years who are specifically supporting startups, and they're okay with making loans based on custom hardware. I think that's a much smaller niche, and there's definitely much more stringent requirements around, kind of what your pipeline looks like and what your financials look like. But it is we are seeing a lot more options in this area as well.
And what's insuring these robots like? I'm getting very technical, but I'm just super interested. If one day I want to start a robotics company, what should I know about insurance?
That's not super fun. I'll tell you that off the bat.
I can imagine that much.
It's possible. I'll say that. It's possible, and it's much more cost effective than you would actually think. The requirements for insuring something really aren't that stringent. Yeah, we haven't had any issues with it. I think the biggest challenge for an early stage startup, especially in the construction space in regards to insurance, is just making sure you have access requirements in place for like workers' comp policies and just general liability policies. Insuring the equipment itself, super easy. I mean, that's something you could just do online. But talking about project access, that's where things can get difficult if you don't have experience in the space. So yeah, I guess forewarning or recommendation is just make sure you're working with the correct carrier and the correct broker when you're starting. So it can make things very difficult if you're not working with the right person.
Okay. No, that's pretty clear. And after zooming in so close, let's zoom, a little bit out for a second. Where do you see Raise in a few years, right? Call it 5 or 6, or in any significant milestone that you want to achieve? Where do you see yourself taking?
I mean, we want to raise robot in every project in the US. But I think like what we really see is that there's a lot of opportunity to really change the way our customers build today. I think we want to have our robots be a standard piece of equipment that our customers use on site. Like when they start a project, when they're planning it, they're thinking, hey, like we're going to be using Raise's equipment on this project. Like let's bake those assumptions into our schedules, into our budgets. I think that's where we really want to be in a few years, is making sure that this is something that's being used, as a daily piece of equipment that's reliable, that our customers can count on.
So as opposed to Boston Dynamics, you want to feel like a cat, basically like a caterpillar.
Yeah.
Our robots don't dance.
Exactly. I love it. And okay, I mean, I took a lot of your time, guys, but what I want to kind of like have closing remarks on is for each of you. So maybe starting with Gary. So just to separate the experiences and separate the feedback. We close off every episode of this series with kind of like an advice to robotics founders that are building hard things. We've had people building spaceships, launchers, Mars rovers, race cars. So we're people building hard things, right? What's your advice? What would you be? What would be the one bit you would give them as a mentor?
Yeah. I think it's always hard to give advice outside of the space because every industry is a little different. I think personally, what's really helped me is just understanding that things are going to take longer than you expect, and that's okay. Like, I think it's something that everybody's well aware of if you ever build hardware. But I think like being patient with it, I think that's something that I would definitely recommend. I think especially since it's not really the good days that you have to worry about, right? It's the bad days and working through those. That's, I think, the area where you just want to make sure you can get out of bed, just go through the day. It's gonna get better.
That's awesome. That's one bit of advice: patience for harder founders. That makes perfect sense. Conley, what about yourself?
I think for me, it would be, make sure you're having these hard customer conversations up front. I mean, before you're too far in the weeds, you want to make sure that you have product market fit, if you can, before you even have the product in hand. So there can be people that build the technology and then try to force it to fit in an application without really hearing their potential customer feedback. But a lot of the times customers will be very upfront with you. It's just about you listening to them more or less. So make sure that you're validating your product early before you're sinking a bunch of capital into it. And with those early relationships, just continue to grow with them. Make sure you have good communication established between early partners and customers as well. They're extremely excited to receive updates. We'll typically send updates every new development or every month to our existing customers, and it ends up helping you sell the product at the end of the day. Gets them excited. They want to share it. They talk to their friends. Ultimately, allows you to get more business.
I love it. So guys, thank you so much for taking the time. I know you have an extremely hard job to do, so I'll let you back to it. Thanks again. I hope I can do we can do a part 2 soon. When Raise is not in every single project in the US, probably it's going to be hard to reach you at that point. But probably a quarter of the way there, that's a good touch point to do a part 2. So thank you so much for jumping up at Builder, you guys.
Well, thank you.
Thanks for having us.